Hi guys, so today we're going to go over independent events for level 3 statistics. So first up, what does it actually mean if two events are independent? So two events are independent if the probability of one event occurring doesn't influence the other. So just some quick examples. Some independent events could look like, for example, your gender and the probability of you flipping a coin. So for example, whether you're male or female, the probability of you flipping a heads is always going to be 0.5. So those two events are independent. Something that is dependent, so these are two events that influence the probability of the other event. So for example, if you can do 20 push-ups, the chances of you going to the gym or exercising are going to be a lot higher than if you can't do 20 push-ups. So the probabilities of the two events influence each other, and they are dependent or not independent. So how do we know if two events are independent? So we use this formula here where the probability of A multiplied by the probability of B is equal to the intersection. Don't worry too much about the notation here. We'll cover it later on. So for this question, let's say that in a class of 32, there's an even number of boys and girls, and there are 11 girls with long hair and 5 boys with long hair as well. Let's say if we wanted to know whether the probability of having long hair in this class is independent from the probability of being a girl. Well, first we need to find the probability of A and the probability of B. So in this case, A would be the probability that you pick a girl in this class, and B would be the probability that you have long hair. Well, there are 16 girls in this class because there's an even number of boys and girls. So we know that the probability of picking a girl in this class is 50%. So what about probability B? Well, we want to know the probability of picking someone in the class with long hair. So there's 11 girls with long hair and 5 boys. So that means that out of the class of 32, there's a 50% chance of picking someone with long hair. So if we multiply these two probabilities together, we get 0.25. And that's supposed to equal the intersection if the two events are independent. So how do we actually figure out what the intersection is? Well, the intersection is just the number of events or the probability of picking an event where A occurs as well as B. So in this example, it's pretty much all the children in the classroom who are girls and have long hair. So we want to find the probability of picking someone in the class who's a girl with long hair. So in this class, there are 11 girls with long hair. So out of a class of 32, we can see that it's not going to be equal to 0.25. It's going to be a bit higher. So we can say that the probability of picking someone with long hair is independent from being a boy or a girl. So alternatively, we can use this method as well, where the probability of A occurring is equal to the probability of A occurring if B occurs. So don't worry too much about the notation, we'll cover it in this question. So for example, let's use the same context. If having long hair and being a girl were independent events, then we would expect half the girls in the class to have long hair. This is because we already know that the probability of having long hair is 0.5. And so if being a girl didn't change the probability of long hair, we would expect half of these girls to have long hair in the class. However, 11 out of 16 girls have long hair, which is not 50%. So the two events are not independent.